Every networking engineer you respect can recite the 7 layers of the OSI model in their sleep. And every CCNA candidate who fails the 200-300 one usually fumbles it in the first 10 minutes. 7 layers, 7 minutes. Let's fix that for life. The OSI model is a 7-layer framework describing how data moves from your laptop across cables and wireless signals to a server on the other side of the planet, and back. It's conceptual, not literal, which is exactly why beginners struggle with it. Cisco loves it on the 200-301 because once you understand the layers, you understand where every protocol, every error, and every troubleshooting command actually lives. We'll break down all 7 layers with one simple analogy, sending a parcel through the mail. Then map real protocols to each layer so you walk into your exam knowing exactly where to look. Start at the bottom. Layer 1, the physical layer. The actual electricity, light, or radio waves on the wire. Copper, Ethernet, fiber, Wi-Fi. If a cable's unplugged, that's a layer 1 problem. The unit of data is the bit, just ones and zeros. Devices, cables, hubs, repeaters, the physical NIC port. Climb 1 floor to layer 2, the data link layer. It packages raw bits into frames so they travel reliably across one local network, using MAC addresses, the burnt-in hardware ID of every network card. Devices, switches and access points. Protocols, Ethernet, ARP, and spanning tree, which Cisco quizzes relentlessly. Mail analogy. Layer 1 is the road and the trucks. Layer 2 is your local postal worker who knows every house on your street and drops the parcel through the right letterbox. Now layer 3, the network layer. This is where IP addresses live and where routers do their job. While layer 2 only knows your street, layer 3 knows the entire planet. It reads the destination IP, checks its routing table, and decides which path the packet takes to a different network. Unit of data, the packet. Protocols, IPv4, IPv6, ICMP, which ping uses, and routing protocols like OSPF, EIGRP, and BGP. Mail analogy. Layer 3 is the international shipping coordinator. It doesn't care about your street, it cares about the country, city, and postcode, and picks the best flight path between sorting centers. If you ever type ping or traceroute, you're working at layer 3. Memorize that. Climb to layer 4, the transport layer, where the network decides how the conversation happens, reliably or quickly. 2 protocols dominate. TCP is connection oriented. It sets up a session with the famous 3-way handshake, numbers every segment, retransmits anything lost, and guarantees order. UDP is connectionless. It just fires data off and hopes. Faster, but no guarantees. Unit of data. A segment for TCP, a datagram for UDP. Port numbers live here too. 80 for HTTP, 443 for HTTPS, 22 for SSH, 53 for DNS. Cisco will ask these. Mail analogy. TCP is a signed for tracked parcel. UDP is a postcard. Fast, cheap, and if it's lost, nobody cries. The top 3 layers are often grouped together because in the real-world TCP/IP model, they're usually one big application layer, but Cisco wants them separate. Layer 5, the session layer, opens, manages, and closes the conversation between 2 devices. Think of a receptionist who connects your call and keeps the line open. Layer 6, the presentation layer, translates and formats data so both sides understand each other. Encryption, decryption, and formats like JPEG, MP4, and ASCII live here. It's the translator converting your letter into the recipient's language. Layer 7, the application layer, is what you actually interact with. Not the app itself, but the network-facing services inside it. HTTP and HTTPS for web, SMTP for email, FTP for file transfer, DNS for name resolution. Open Chrome, type a URL, and you fire data into layer 7, which cascades all the way down to layer 1 to hit the wire. A memory trick that saved a million candidates. Layer 7 down to 1. All people seem to need data processing. Here's what nobody tells you. The 200-301 rarely asks, what is layer 4 outright. Instead, it gives you a scenario. A user can't reach a website, a switch port is disabled, a ping fails, and expects you to identify which layer the problem lives at. So train your brain to map every protocol, device, and command to its layer. Cable unplugged, layer 1. MAC table issue, layer 2. Wrong default gateway, layer 3. Firewall blocking port 443, layer 4. DNS down, layer 7. Master that mapping and you've already passed the OSI section. If this finally made the OSI model click, do me one favor. Hit subscribe, because 3 to 5 videos a week drop on this channel, all aimed at getting you CCNA certified without the textbook headache. And drop a comment with the one layer that still confuses you most. I read every comment and I'll turn the top answer into a deep dive video next week. Up next, we're zooming into layer 4 and breaking down TCP versus UDP, the three-way handshake, port numbers, and why one streaming service uses one while a video call app uses the other. It's another exam favorite and it pairs perfectly with everything you just learned. Hit subscribe and I'll see you in the next one.